Hello and welcome to episode 145 of the HamCorp Training Manual. In this episode, we will construct both the SSASS and the SLAM, and we will cover, in detail, the mechanics of these two multis. After optimizing, we also go over the automation setup for the SSASS. This is quite an in-depth analysis, so this episode will be a fair bit longer than the usual episode. Very cool. Now let's talk about how this multi works, and I'm going to figure out how to automate it before I build more of them. One quick thing I want to mention though is that it doesn't accept wireless energy hatches for some reason. So you have to provide a normal energy hatch or a laser hatch. Also, it doesn't say in the tooltip that it accepts multi-amp and laser hatches, but it does. Now, let's look at this enormous tooltip together. This machine converts protomatter into antimatter, and it consumes 10 million plus antimatter times 1000 to the 1.5 EU per tick passively. And when it's actively doing stuff, it uses an additional antimatter times 10,000 to the 1.5 EU. Every cycle, the lowest amount of antimatter in the 16 antimatter hatches is recorded, and every cycle means every second. All hatches with more than the lowest amount will lose half the difference. So if you have one hatch with 0 antimatter, and all the other hatches with 1000 antimatter, at the end of the cycle, all the hatches that have 1000 will lose 500. If the machine runs out of energy or protomatter during a cycle, 10% of antimatter will be voided. That's pretty straightforward. The machine produces antimatter to the 0.5 times n of 0.2 and 0.25 of antimatter per cycle, consuming equal amounts of protomatter. This change is split between the 16 antimatter hatches, sampled from n of 0.2 and 1. So n is a Gaussian distribution, where the first parameter is the mean and the second is the standard deviation. And it says here the total change can be negative. So let me show you what this Gaussian distribution looks like, and then it'll make more sense. Now, here I am in Desmos. This is the function. This is a Gaussian distribution. S here is the standard deviation, and m is the mean. So that first function we saw had s equals 0.25 and m equals 0.2. And this is the probability distribution function that the machine will sample from. So every cycle, it's going to pick a number from minus infinity to infinity based on this probability distribution. So the most likely choice is going to be 0.2. And then symmetrically on either side, the probability of a specific number on the x-axis getting chosen decreases. Importantly, the amount of antimatter generated can be negative because the probability of numbers below 0 is not 0. So it's possible to get these values. It's less likely than getting a positive value, but it is still possible. The second function had a standard deviation of 1. This is how it gets distributed between the hatches. So a certain amount of antimatter gets generated, and then the change in each hatch is decided by the second function, which has a larger standard deviation. Let's say we generated 16 antimatter in our first cycle. Each hatch is going to receive a different amount based on this distribution. Some of them can be negative, some of them can be positive. The overall gain will still be 16. Remember that the overall gain can still be negative, but weirdly, some hatches can still gain material when the structure overall is losing material. Now, to manipulate parameters, we can supply different stabilization fluids to improve the antimatter generation. First, there's magnetic stabilization, molten purified tangum, or tachyon-rich fluid. I'll be using the tachyon-rich fluid, of course. This reduces the passive cost exponent by 0.3. So instead of 10 million plus antimatter times 1,000 to the 1.5, it'll instead be to the 1.2, which is a lot better. Next, gravity stabilization. I can either use molten spacetime, spatially enlarged fluid, or when I get it, molten eternity. I'll be using spatially enlarged fluid for now, and this reduces the active cost exponent by 0.1. So instead of to the 1.5, it's to the 1.4. Containment stabilization. I can either use molten Shirabon or molten magnetohydrodynamically constrained star matter, or MHD CSM. I gotta find a short way to say that. Mag star matter or something. But this increases the production exponent by 0.05 or 0.1. I'll be using the Shirabon because I don't have access to the mag star matter, so plus 0.05 it is. And finally, activation stabilization. I can either use depleted Naquata fuel Mark 5 or Mark 6. And it says here distribution skew, but that is a different thing. This bothers me a little bit. But what's happening here is not a skew, it is a mean translation. Mean translation is a good thing, as long as the mean is being translated to the right. So with Mark 6 depleted NAC fuel, the mean goes from 0.2 to 0.3. So everything shifts to the right a little bit, and that's true for both the Gaussian distributions that we're sampling from. Because shifting to the right means the probability of getting a negative number is lower. So this is a good thing. Skew is something else. This is skew. This is not what's happening, but it's still cool. It's funny because a positive skew would be a bad thing for us because more negative values would be more likely to be picked. So we actually would have wanted a negative skew. I actually don't even know how to write a function that has skew. I think it's pretty weird, but luckily, that's not what's happening. It is not a skew, it's a mean translation, so that's a lot easier for me to think about. Now, I'm going to try and figure out a way to automate this, and then I will be back. Upon further inspection, I need to consider how the antimatter is actually used. Because the more antimatter I want to make, the more antimatter I need to have. And the more antimatter I have, the more EU it costs for an operation. And that amount increases exponentially with the amount of antimatter. So by having too much antimatter in my hatches, it would be very easy to use so much EU to make more antimatter that burning it doesn't give me an energy profit. And that is a big problem because the whole point of this is to make power. So I think I need to set up a Shielded Lagrangian Annihilation Matrix first, and also understand how this operates, and only then can I really optimize and automate this properly. So hopefully you remember everything I said about the SSASS, and you can keep it in your head until I actually get back to automating it. Good luck with that. The SLAM. How does the SLAM work? And how does it tie in to the SSASS? So, the SLAM generates energy by reacting semi-stable antimatter with matter. There's only certain types of matter you can use, and based on what matter you use, you get more energy. So it consumes all inputs every processing cycle, and imbalance between antimatter and matter will waste energy or material, or both, I guess. And any EU that doesn't fit in the laser hatches will be voided. Every cycle means every tick, I believe. I haven't actually tested it, but I think every cycle is every tick. And as for this laser hatch thing, there's some math involved to see how much energy I'm actually going to get from reacting the antimatter with regular matter. And based on that math, I have decided to use UMV 16384 amp laser source hatches. There's 64 of them around the entire structure, so you can do the math. One important thing to note about the math when you do it is it's not the throughput that matters, it's the capacity. So the SLAM just takes the inputs, converts it into energy, and stores it in the source hatches. Now normally you would need to wire this up to an LSC to upload to wireless, but you actually don't need to with the SLAM because it has wireless mode, with one small caveat that wireless mode is only possible with the molten superconductor UMV base and with the molten black dwarf matter. On top of all this, you cannot produce more than 9.2 times 10 to the 18 EU per cycle. I'm not going to be making that much, so I don't need to think about that just yet. It also tells you the base antimatter energy value, which is 1 trillion EU per liter. Unfortunately, not in the tooltip, but fortunately in the quest, it tells you exactly how this exponent factors in. So the generated EU is the amount of antimatter you burn to the power of exponent times a trillion. I'm going to be using UMV superconductor base, of course, because I need the wireless capability. And so that means I'll be getting antimatter to the 1.03 times a trillion EU per liter of antimatter. Now, time for some math. Given that we know how much EU 1 liter of antimatter is, how much antimatter do we need to generate per cycle of the SSASS? And this ended up being quite a fun calculation, so let me bring it up. Alright, let's see if I can explain this, but I think I'm going to struggle. This first equation, and the first graph I'm going to show, is the amount of energy that goes into the SSASS for 1 second in order to generate antimatter. I'm using 1 second and not 1 tick because the cycle of a SSASS is 1 second long. This first term is the passive cost. That's why it's multiplied by 20, because this is the EU per tick required, times 20 ticks per second, gives me this much. And the second term is the active cost. So this quantity is the total amount of EU that goes into the SSASS given an x-axis amount of antimatter that is split among all the antimatter hatches. The second term shows how much antimatter I'm going to generate in that 1 second. The first term is just antimatter to the exponent, and based on my fluids that I'm going to be supplying, my exponent will be 0.55. You can go all the way up to 0.6, and that doesn't sound like a big difference, but it's actually enormous. And then this factor is the peak of the Gaussian, the height of the peak of the Gaussian. Remember the Gaussian had a term that was like e to the minus x minus mu squared over 2 sigma squared. This part is maximized at a value of 1, and that happens when x minus mu is 0. So x is equal to the average, which makes sense. That's the most likely amount of antimatter to be generated. So on average, we will make this much antimatter every cycle. The second graph, E output, takes the amount of antimatter we produce and we send it into the SLAM and we convert it into energy. So every second I'm going to make a produced amount of antimatter, and every second I will burn it all. My exponent will be 1.03 because I'm using the superconductor base UMV, and times a trillion, which is the base value. So as you increase the amount of antimatter in your SSASS hatches, the cost of making the antimatter eventually grows larger than the EU you get from burning it. And so this intersection point is the maximum amount of antimatter you can have in all your hatches before making antimatter actually becomes a net negative. What we care about is the difference of green minus red, right? And that's what this is. So there is a peak here, and there's also a point where it crosses 0. Where it crosses 0 is the intersection point I mentioned before, and the peak here is the optimal amount of antimatter to have in your hatches. This is where the EU profit, which is what the y-axis is maximized. So if possible, you want to be in this area. As long as you're anywhere positive, you will be making energy instead of losing it. This peak happens to be at 12 million liters of antimatter for me, for my specific set of input fluids. And that is a lot. So I need to build up to that amount, which is going to be a pretty big EU investment. But once I'm there, I will be making 4.8 times 10 to the 15 EU per second. Of course, we care about EU per tick, so it's a 20th of that, but still, that's a lot. That is a lot more than I make right now. And specifically, we also care about the actual values here. So every cycle, I'm going to make 6.2 buckets of antimatter. Every cycle of the SSASS, I'm going to have to spend 3.26 quadrillion EU. So I need to be able to power that for a whole second, which is something I need to think about with the laser hatch. And every second, I will be making 8.1 quadrillion EU. I guess it doesn't have to, but it's better for me to do the entire antimatter in one burn rather than dividing it up into multiple burns. And I'll show you why in a sec, but ideally I will be able to hold this much EU in all of my laser hatches combined. And I think I will be, but I gotta double check that. And by the way, the reason you want to burn all the antimatter at once is, look at this. This top equation is the amount of energy you get from burning your entire batch of antimatter at once. And the bottom is how much you get for burning half of it in 2 sets. So if you look at the ratio of these two numbers, you get this quantity, which is about 1.02. So it's not a big deal, but you do get about 2% more power for burning it all at once compared to doing it in halves. But the more you subdivide, the more of an impact it has. So if you do 100% of your antimatter, you get a certain amount. And then if you do 1% of your antimatter 100 times, you get another amount. And the first is 14% bigger than the second. So it is better to just burn everything at once if you can. Right, I hope that was sufficiently difficult to follow, but now I need to automate this and explain that, and surely that will be even worse. All right, I think I have a working setup. It's off now though, because I'm not making Shirobon fast enough to make NAC Fuel 6 fast enough to keep this going all the time. I have a small amount of NAC fuel that I can use for demonstration, but right now this thing is off. Before I demonstrate, let me actually show you the setup. So it all starts here on these antimatter hatches. There are 16 of them. All of them are facing sort of inwards. So they all are going to face this black network. And on this black network, touching the front face of all of these hatches, there is a fluid storage bus set to extract only. And there's 16 of them around the entire structure, and they all come together into this one black subnet, where I also have an MEIO port. And this MEIO port is slightly separated from the subnet with the use of this toggle bus. The MEIO port has hyperacceleration cards, a single type storage cell, and operation mode is set to move to output when work is done. And the transfer direction is into the cell. So what happens is, at some point, which will make sense later on, this signal will come on. This lever is here for troubleshooting, but this signal will come on, turn on the toggle bus, and then this fluid storage cell will suck up all of the antimatter from all the antimatter hatches, contain it all within itself, and then move into this output area. From there, I have a conduit that's pulling anything except an empty fluid storage cell. So that's blacklisted, and it's always on. It pulls the storage cell with a variable amount of antimatter inside of it, and puts it into another IO port on a white subnet. Here the operation mode is move to output when empty, there's hyperacceleration cards, and the transfer direction is into the network. So the cell comes in with fluid, is emptied out, and then an empty cell is returned at the end here, and that is pulled automatically by the same conduit and returned to the first MEIO port. But where is all this fluid stored? The answer is this super tank on the left. There are 2 super tanks due to a little quirk that I'll explain in a bit, but this is the main super tank. So all of the fluid, once it's cleaned out from the hatches, gets stored in this super tank through this fluid storage bus set to insert only. And on this face of the super tank, there is a UEV electric pump, always exporting. And all the fluid gets sent into this P2P tunnel. This is the input side. And it's a fluid P2P. Now, from working on the solar towers, of all things, I discovered that the P2P tunnels, at least the fluid ones, round robin the fluid. So that is super useful for this. So fluid goes into the P2P tunnel, and then back on these antimatter hatches on the back side, there is a set of 16 P2P fluid outputs. So the fluid goes into the tunnel, comes out of these outputs, and is round robined into every single antimatter hatch. So it will be perfectly balanced every time, unless the amount of fluid that is sent into the round robin network is not divisible by 16. If it's not divisible by 16, the last hatch that's connected gets less than the rest of them. And that is a pretty major problem when you have a small amount of antimatter. With a large amount of antimatter, it kind of doesn't matter so much, but I don't have a large amount, so this actually does matter for me. Now, I just said the last P2P tunnel is the one that receives the least fluid. So instead of 16 P2P outputs here, I actually have 17, and that's what this second super tank is for. So the first 16 outputs will always get an equal amount of fluid, and then the odd one out, which is the last one that has been bound to the input over here, will get the strange amount that isn't divisible by 16. This super tank has 3 covers on it. It has a fluid detector cover set to 2047 and normal mode. The top face has a machine controller cover set to enable with redstone. And this face, the one that's touching the main super tank, has a fluid regulator, use machine processing state, and it does 1024 liters every 4 ticks. I didn't set a number every tick because I found that the time it takes for the redstone signal to activate was slightly longer than a tick. I think it's 2 ticks for redstone rate. So that actually made this not work, but this setup does work. It does mean that I need to cross 2047 antimatter in this tank before this starts to correct itself. But what happens here is the antimatter gets distributed, a weird amount gets stored in here. If that amount is more than 2047 liters, then it gets put back into the super tank in increments of 1024, which is divisible by 16. So those increments also get split among the different input hatches, and everything remains balanced. And these increments keep going until I have an amount in the secondary tank that's less than 2047, or less than 2048, actually. So it's like there's a first initial balancing, and then the overflow is balanced again. And if there's more overflow because of that balancing, that will be balanced again. So it's kind of recursive until there's less than 2048 in the secondary tank. I think that's pretty cool. Now that's all the AE2 logic. I mentioned this redstone signal earlier. Let's talk about that. Right now, this system, it works and it's fine and I'm happy with it, but it's not going to let me have 100% uptime with the SSASS because I don't think all of this can happen within 1 second. Maybe it can. I'm just too scared to test it because antimatter is quite precious to me right now. But maybe later on, if I need to refactor this when I'm upgrading things, then maybe I'll test it more properly. But for now, this is fine. And what I've done here is everything starts with this timer. Timer is set to 4 seconds. That means every 4 seconds, a pulse is sent out into this red alloy wire. 1/2 of the pulse goes into the machine, goes to the machine controller, and just turns it on. I'm now realizing I have an activity detector cover at the bottom that I'm not using at all. This is part of a different idea, so that's not supposed to be there. Anyway, every 4 seconds, this pulses on and does a 1 second cycle of its craft. And at the same time, when this pulses, there's a 16 tick delay, which goes to this wireless transmitter. And this transmitter is the same as the signal I was talking about before. So the machine turns on, 16 ticks later, the fluid in the hatches gets cycled and rebalanced, and then everything waits until the next timer iteration. 4 seconds, I think, is more than I need. I think I could get away with 2.5 seconds or 2 seconds maybe, but I'm happy with this. Over here, I have a couple of logic gates. I don't think the logic here is too important for me to explain, but basically what this does is there's another wireless receiver here that goes to the top where there's a bunch of OR gates and some fluid level emitters on another subnet that basically says if this subnet doesn't have enough of the inputs, don't do anything. Keep the machine off. And right now, my main problem is I'm missing depleted Mark 6 NAC fuel, which, by the way, this also makes so much power. My current NAC fuel setup in the power building makes about as much as my Dysons do, except they're not on all the time. So I need to work on making more Shirabon and more depleted Mark 6 fuel, which means I need more DTPFs and more convergence, which in turn probably means I need to make more exotic catalyst, which means I need more compact fusion. Here we are, back at compact fusion yet again. That is a problem for later. For now, antimatter. Let's do a quick demonstration. I need to leave this running until I have 12 million antimatter, so I don't even want to burn any until that point, so I guess the slam is going to have to wait for a bit. Anyway, let's turn this thing on. Gain a little bit of antimatter, gain a little bit more. I'm going to do 10 runs of this, just see if they're positive, more than they're negative. If they are, then I'm happy. That's 3 positive, 4 positive so far. So far, it's only been positive values, which, while that makes me happy, it's kind of hard to say if it's actually working correctly. What if I'm just getting lucky? I don't think I am. I think this is genuinely working correctly, but the weird thing about this multi is because even if everything is set up perfectly, you can still lose antimatter just because of how the RNG works here. So it's really hard to tell if I've set this up right without doing like a large data sample and analyzing it to see if it's actually following the Gaussian distribution that I expect. And I don't want to do all that. But so far, antimatter has been going up. Sometimes it looks like it's going down, but that's just because sometimes it gets stored in this secondary tank and it gets stuck there because there's not enough to cycle more. But yeah, I think I'm pretty happy and pretty confident to say that I am gaining antimatter much faster than I'm losing it. So this has been set up correctly. Oh, finally, a negative number. Anyway, I'm going to turn this off because I don't want this to run unless I have enough depleted Mark 6 NAC fuel. But this should work perfectly fine. Thank you for watching this episode of the HamCorp Training Manual. In the next episode, we begin the journey towards the final multi-block in the game, the Eye of Harmony. HamCorp would also like to thank all its employees for contributing to the company. We are now 5,000 strong. We appreciate your support and expect you to work 5,000 times as hard to bring all the new employees up to speed. See you next time.